Today we're going to look at comparing functions. One of the things you already know is that the steeper the line, the greater the rate of change. So if we look at this function here, and this function here, this function has a steeper line. It is changing at a greater rate. Greater rate. Now look at these two functions. Which one do you think has a steeper line? Do you think it is graph A or graph B? If you said graph B, then you would be correct. Graph B has a steeper line. It has a greater rate of change. We can also compare the rate of change by looking at a table. Remember, when we are deciding what the rate of change is, we look at the change in our y over the change in our x, the change in our dependent versus the change in our independent. So when we are looking at this graph here, or this chart here, let's determine our change in y versus our change in x. Our change in y from this point to this point is 2. Our change in x from the same two places in the graph is 1. Our rate of change then is 2 over 1, which equals 2. This has a rate of change of 2. When you're comparing charts, such as this one, if you don't already know that it's linear, meaning that it has a constant rate of change, you would need to check and make sure that the rate stays the same. From here to here, we have a change in 2 and a change in 1. From here to here, we have a change in of 2 over a change of 1. So the rate of change for this entire chart is 2. From this point on, every time we see an XY table, the assumption is that it is a linear graph, and so the rate of change is the same as constant, so you'll only need to check one part of the graph, of the table. Now let's look at this XY table. Our change in y, -3 to 0, is 3. Our change in x, -1 to 0, is 1. 3 divided by 1 is 3. So our rate of change is 3. Now let's look at two XY charts side by side and determine which has the greater rate of change. For our first chart, from 0 to 1 is 1. From -1 to 0 is 1. 1 divided by 1 is 1. Our rate of change for this chart is 1. Let's look at our second chart. -1 to 0 gives us a 1. -2 to 0 gives us a 2. 1 divided by 2 is 1/2. So this chart has a rate of change of 1/2. Which one has the greater rate of change? Which is the bigger number? 1 is greater than 1/2. This chart has the greater rate of change. You can also compare rate of change by looking at equations. Remember, when we are looking at our equations, we can determine our rate of change very easily. The number, that coefficient in front of our x, is our rate of change. The number at the end, in this case +1, a positive 1, is our initial value. Think back to our Chenoweth, Chargers, and Mazikh-Maniac rate of change problem. This is that value when x is 0. It's the value where x crosses the y-axis. We also call it the y-intercept. We also call the rate of change slope, and we've referred to it that way before. The y and the x, that is how we determined what our ordered pairs are. You substitute in a value for x, you get the y that it goes with, and that gives you your ordered pairs. Let's look at these two equations. Remember, our rate of change is the number in front of that x. So in this case, the rate of change for our first equation is 3. Our rate of change for our second equation is 2. This equation has the greater rate of change. You can also see that this equation crosses the y-axis at 2, and this equation crosses it at -1. Now let's look at these two equations. Which one do you think has the greater rate of change? If you said this equation, you would be correct. Its rate of change is 5. The rate of change on this equation is 3. 5 is greater than 3. Now, which one do you think crosses the y-axis at a +2? If you said this one, you would be correct. It crosses the y-axis at a +2. This equation crosses the y-axis at a -1. Remember, you can determine the rate of change by looking at a graph. We need to determine the rise, which is our change in y, and our run, which is our change in x. Our rise and our run between two different points on our line. On this graph, our rise, our change in y, is a +4. 1, 2, 3, 4. And our run is 1. Our rate of change for this equation is 4. Now, remember, since the graph is going up, it's always a positive slope. Our rate of change for this particular graph is 4. If we wanted to write it as an equation, we know our rate of change is 4. Let's see where it crosses the y-axis. It crosses us right here. That is our origin, which is 0. you would simply write this as y equals 4x. Let's look at this chart. Our rate of change, -3 to -1 is 2. 0 to 1 is 1. Our rate of change is 2. If we wanted to put it in an equation, we know that we need to put our rate of change in front of the x. And we can see from the chart that when x is 0, it crosses the y-axis at a -3. So we would simply put a -3. Now don't worry, this is something that we're going to talk about quite a bit, but I just wanted to give you a peek at what you do when you're looking at a chart to turn it into an equation, or if you're looking at a graph to turn it into an equation.